Hi everyone, welcome to RoshChem summary videos. In this video, I'm summarizing the lesson covalent bonding. So covalent bonds are formed between nonmetals. So when nonmetals make covalent bonds, they share electrons. First, we will look at Lewis structures. So we'll take the Lewis structure of ammonia. So ammonia contains 1 nitrogen atom and 3 hydrogens. Okay, so to find the Lewis structure, first we will see how many valence electrons in nitrogen. So if you take nitrogen atom, it's from group 15. So it got 5 valence electrons. So first write the number of valence electrons, and each hydrogen got 1 valence electron. Then to become stable, so becoming stable means getting 8 electrons to the valence shell. So nitrogen needs 3 more electrons. So this is how many valence electrons. And then to become stable, nitrogen needs 3 more electrons. And each hydrogen, so they can become 2 electrons. By hydrogen, they become stable by getting 2 electrons. Therefore, each hydrogen needs 1 more electron to become stable. So this is the number of electrons that they share. So if they need 3 electrons, so they will share. So nitrogen then will share 3 electrons. Each hydrogen will share 1 electron. Okay, so how do we do the Lewis structure then? So you have nitrogen in the middle and then 3 hydrogens around that. So nitrogen out of 5 valence electrons, now it's sharing 3. So put 3 electrons per share between hydrogen. So I can do crosses or dots here, right? So out of 5 electrons, I'm sharing 3 electrons with hydrogen. So I put 1 electron I give 1 electron to each hydrogen, and the other 2 electrons are not shared. So these are called the lone pairs. Now, if you take hydrogen, each hydrogen got only 1 electron, and that electron, it is sharing now. So then you can share the electron of hydrogen with nitrogens like that. Okay, so this is the Lewis structure of NH3. Now, if you look at the Lewis structure of NH3 around nitrogen, you can see the nitrogen atom now got 8 electrons. So 2, 4, 6, and with this 2, it got 8 electrons, and each hydrogen now got 2 electrons after sharing. So in this Lewis structure, these 2 electrons which are not shared are called the lone pairs, and these electrons are called the bond pairs. Okay, we will also look at the Lewis structure of water. So water is H2O. So you have 1 oxygen and 2 hydrogens. So the valence electrons in oxygen, it's group 16, so 6 valence electrons, and each hydrogen is 1 valence electron. So therefore, to become stable, oxygen takes 2 more electrons and each hydrogen takes 1 electron. So this is the number of electrons that oxygen is sharing then, whatever the number of electrons that oxygen needs. So that's the same number of electrons that oxygen needs sharing. So oxygen will share 2 electrons, hydrogens will share 1 electron. So put oxygen in the middle, then you have 2 hydrogens. So now oxygen out of 6 valence electrons is sharing 2. So I can give 1 electron to hydrogen, the other electron to the other hydrogen. So from 6 I have shared the 2. So I have 4 remaining. So now I can do 2 lone pairs like this. Then hydrogen, it only got 1. So it's sharing that 1. So now you can share that electron. So now this is the Lewis structure of water. Right, so now you can see around oxygen, you have now 8, so 2, 4, and 6, and 8 electrons. That oxygen atom became stable, and also hydrogen atom became stable by having 2 electrons into the outer shell. So this is called the Lewis structure. So sometimes I can say electron cross diagram, or I can even say electron dot diagram, or electron dot and cross diagram. Now we will see how to draw the valence structure. Okay, the valence structure of ammonia is given here. So now we got the Lewis structure. So I will redraw the Lewis structure of ammonia here. So we had a lone pair, and then we had 3 bond pairs like this, and these are the hydrogens. Okay, so you can see in the valence structure, we show the bond pairs by lines, right? So you have two electrons or 1 bond pair. So that is a bond, that's a single bond. So this is another single bond, and that's the third single bond. So nitrogen got now 3 single bonds, and it also got 1 lone pair. So you can show the lone pair with 2 dots, or with 2 crosses, or even with a small line you can show the lone pair. So you can do the valence structure like this, NH3, and the lone pair you can show with a small line like that. That's how we do the valence structure. And for water, then how do we do the valence structure? You got oxygen in the middle. So oxygen had 2 bond pairs, so 2 bonds then. And also oxygen got 2 lone pairs, so those 2 lone pairs I can show by 2 lines like this. Okay, now we will find the shapes of molecules. The first one is called linear. So remember, diatomic molecules are always linear. So molecules like H2, N2, right, Br2, they are always linear. So when it comes to polyatomic molecules, to find the shape, there are several rules. So we will go through those rules to see which shape will be the molecules. Okay, the first one, so number of bonding electron groups around the central atom, and number of lone pairs around the central atom. To determine the shape, so I need to see 2 things. So one is how many bonding electron groups around the central atom, and then I also have to find out the number of lone pairs around the central atom. So if a molecule has 2 groups around the central atoms, like in carbon dioxide, right? So this is the central atom. Now around the central atom, the bonding electron groups, so carbon dioxide, carbon is the central atom. Around carbon, I got 2 bonding groups, so 2 oxygen atoms, right? So then that is 2, and the number of lone pairs around the central atom. On the central atom, you don't have any lone pairs, that's 0. So if it is 2 and 0, I say the shape is linear. Like to get linear shape for polyatomic molecules, around the central atom, you should have 2 groups or 2 atoms like this, and the central atom should not have any lone pairs. Then you get the shape linear. Okay, we will go to the next shape now. The next one is trigonal planar. So to have trigonal planar, around the central atom, there must be 3 groups. So like this is the aluminium atom, the central one. Around aluminium, you got 3 chlorines, but no lone pairs again on the central atom. So no lone pairs. So then I say the shape is trigonal planar. So how do we draw trigonal planar? This is the aluminium metal in the middle, and these are the 3 chlorine. So this shape is called trigonal planar shape. So in trigonal planar shape, you can see all the angles are equal and they are 120 degrees. Okay, the next one is pyramidal. So pyramidal is, again, in pyramidal, around the central atom you should have 3 groups, but also you got 1 lone pair on the central atom. So like ammonia. So nitrogen, around nitrogen you got 3 groups, 3 hydrogens. Also the nitrogen got 1 lone pair. So when you have 3 and 1, you say the shape is pyramidal. So how do you show the pyramidal shape? That's a 3D shape. You can see that's the nitrogen atom in the middle. And these are the 3 hydrogen. The lone pair will sit on the nitrogen atom from the top like that. Right? So this is the pyramidal shape. So to have this pyramidal shape, you need to have 3 groups around the central atom like this. And also you should have 1 lone pair on the central atom. Okay, the next one is tetrahedral. So to have the tetrahedral shape, we should have 4 and 0. So 4 and 0 means around the central atom, there must be 4 groups like this, right? So this is the central carbon. Around that, now you got 4 hydrogens. And also there should not be any lone pairs on the central atom. So it's 4 and 0. So that makes tetrahedral. So this is the 3-dimensional 3D shape of it. So this is how tetrahedral looks like, right? That's the middle carbon, and these are the hydrogens around that. Okay, the last shape is called bent. So to have bent shape, we should have 2 and 2, which means around the central, you should have 2 groups, and also the central atom must have 2 lone pairs. So you can see this is the central atom, which got 2 hydrogens, and also the central oxygen got 2 lone pairs. So that makes the shape bent, or else we also say V shape. So this is how the bent shape looks in 3D. Right, that's the central oxygen atom, and these are the 2 hydrogens around that. Okay, so that's the summary of this lesson. So now it's time to do questions. You can find questions and summary notes on pages 45 to 55 from RoshChem 1 and 2 study guide. Okay, thanks for watching my video. So if you need any extra help, you can email me, or else you can visit our website www.roshchem.com. Thank you.